This has nothing to do with money. That's odd. What does it have to do with? Yeah, so we're going to add a little note here. What we really use this formula for is population growth. It's because babies are born every second of every day, of every week, of every year, of every month. I'm sure hospitals would love if we could schedule them once a week or once a month, but yeah, that doesn't happen. Did you guys hear about the twins in San Francisco that one was born at 11:59 on New Year's Eve and one was 12:01 New Year's Day? So they're now born different years? Yeah, so now they'll go to school different years? That's so weird. I'm sure they will change one. But okay, what's important? What do we need to know here? After on makes no sense, so I think we want to say on what date, so take out the after there. So in terms of our A, our P, our E, and R, or our T, what is 500 going to be? That is our P. It's our principal, our starting amount of gophers. What's the 2.5%? R. What is 950? It's A. It's the amount afterwards. Where's our T? Yeah, something to do with May 1st, but really it's what we're trying to find, is what date is this going to be 950? Okay, so A we said was 950. P is 500. E is E. What do we need to put for the rate? Okay, which would be 0.025. And then T we don't know yet. Peek at example 3. What was the first thing we did in that example? Divide by the 500. It's the same thing here, just to get rid of it. Again, just repeating, you don't have to divide by the 500. It just makes the log work easier. Even? Peek at the last example. What was the next step that we did? Why natural logs? Why not regular old logs? Yeah, because we like that fact that it cancels out. What did we do next in the last example? $10.186. Nobody saying anything? Sorry, say it again. 0.674. Confirm. But that's not a date. That's just the number of days. So how do we figure out what date? Okay, so add on to May 1st. So if we take May 1st and we add the 25 days, we're at May 26, and it's going to be a partial day, so it's going to be May 27th. Just make sure you're answering the question.
Or we could put the 0.67 into hours.
No, the 25th at the 25 days at the end will be May 26th. So it'll be the next day because you were already on the 1st. So if this was 1, it would be the 2nd. If this was 2, it would be the 3rd. So 25th has to be a full 26 and then partial day. Approximately 11 p.m. Good to know. Good to know. Do you see the similarity between example 3 and example 4? Right? Interest, people, population, we don't care. It works the exact same way. Last type we're going to do is called decay. So a bit of biology here, a bit of chemistry. And what's different with this type than the other ones is there isn't one particular formula. It will be given to you in the question depending on the substance. So they're telling us for this particular substance, there's the formula how it decays. That negative 0.2 will change depending on what the item is.
Negative 0.2.
Yes. They've defined the variables. They've said A is the original amount and Y is the amount remaining after X years. And part A, we want to know if A is 80 grams, how much is left after 3 years. And then something about half-life, which we'll come back to. Hardest things with one like this is just trying to figure out what am I putting in for what variable. So we've got to figure out what's this 80, what's the 3, what am I trying to find. The 80 is pretty clear because the question has told you that is 8, or is 8. So I'm going to put 80 in there. What's the 3? Is it the Y or is it the X? Well, this is why they define the variables for you. Which one has to do with time? X, so this one is 3. What do we put for Y? Why? We don't know. That's what we're trying to find. Exponential or logarithmic? How do you know? How do you know if something is exponential? There's a variable in the exponent. Is the variable in the exponent? So it's not exponential. Is it logarithmic? No. How do you know it's not logarithmic? Because there's no log in it. So what is this? This is a straight up calculation question. Y is already by itself. So don't think just because it's in this unit, it's always going to be a log question. This is a straight up plug it into your calculator. If you have the old operating system, you're going to want to bracket the exponent. If you have the new, you should be okay. But this is not a log question. This is just a straight up calculate. If we go to 3 decimal places,
905.
some units. I heard somebody say grams. Confirm. Yeah, G. Turn and talk. Tell your partner why we didn't use any logs in this question. Half-life. Half-life is a term comes up in bio and chem. It's usually used when forensic scientists are looking at different crime scenes and they want to know what's happened to different stuff. Anyone want to guess what the definition of half-life is? Half of what? So it's when So it's when the original amount, I think I spelled that wrong, original amount will decay to half. So what we're looking for is a time. How long will it take till there's half the original amount? So for example, if A is 80, like it was in part A, what do we want Y to be? 40. Let's say they gave us A was 25. What would we want Y to be? Let's say they gave us A to be 100. What would we want Y to be? So what's the relationship between A and Y? So Y equals 2 times A, or A divided by 2? Because I just heard both of them. I just heard both of them again. Fight it out. It's A divided by 2. So Y has to equal a half of A. So the question may not even give you values, and that's fine, because you can put in any numbers you want as long as Y equals half of A. You could put in 2 and 1. You could put in 1 and a half. You could put in a half and a quarter. You could put in 1,000,000 and half a million. It doesn't matter what the numbers are. So sometimes on the exam, they'll just ask half-life, but they won't give you the value of A. And that's okay, because we know that it's double. So same formula from before. We can use 80 for A, but we don't have to. If we choose to use the 80 for A, what's our Y value? Okay, so let's just make a note. These can be any value. As long as Y is half of A. Okay, look back at the 4 examples. See if we can apply it to this one. What's the first thing we did in those? What do you think the first thing is we're going to do here? Divide by 80, because we want to get rid of it on this side. So if we divide both sides by 80, what happens? 1/2 equals? And just making a note, that's why we call it half-life. Because that side will always be a half once you simplify. Okay, after we divided, what did we do? Okay, what did we do after that?
Divide both sides by -0.2 for a grand total of 3.466 with rounding.
Looking for confirmation?
Oh, why not? 0.66.
Hey, did you maybe put 0.02 instead of 0.2? Might be right though, might be, I don't, you guys confirm, I don't, so.
Okay,
Anybody else get the same or different, or? Yeah, it makes sense, because up here, what we know.
It's -0.2.
oh no, he's right, yeah.
Okay, some units?
Years.
Years. Half-life is always in years.
I know my -0.
Questions so far?